Hello and welcome from A to Z, Azure Virtual Concert. This is A to Z, Growth of Data. My name is Brian Nielsen. I'm a Senior Cloud Training Architect with Ops Agility. I've been working with IT over 26 years, and I spent 11 years as a consultant with various Microsoft partners. If you do need to contact me, my email address is down at the bottom, also with my LinkedIn profile. For our agenda for the day, we're going to delve in a little bit about big data, also look at some different data platforms that are out there, look at the entire Azure data portfolio and do some demos, and then we'll go into some of the non-relational systems that are available from Azure and do some demos of those also. Understand that data volumes have actually skyrocketed. So more data has been generated in the last 2 years than the entire human history before that. So think about that number. It's an actually massive number. And since 2012, big data has created 14 million jobs. To put some other numbers on here, people share more than 100 terabytes of data on Facebook daily. Every minute, users send 31 million messages and view 2.7 million videos. Each minute, there's 300 hours of new video that shows up on YouTube. That's why there are more than 1 billion gigabytes available on YouTube. Smart devices, for example, these could be fitness trackers, sensors, Amazon Echo. This produces 5 quintillion bytes of data daily. When you're actually moving to the cloud, it can improve a business's agility by 29% and also shorten your payback times by 30%. And as you can see in the chart to the right, the amount of data stored has doubled in the last 2 years. If you look at this chart, you can see that 10-year data center storage forecast, there's an extreme trend to get out of traditional storage techniques, utilizing capitalized expenditures and switching over to operationalized expenditures, which is available inside all the cloud platforms. When you consider the cost of keeping existing hardware in your existing data center, not only does it lower the cost and lower the administration of a cloud instance, but you no longer have to worry about buying and supporting physical hardware anymore. This is going to have dramatic savings on your data center costs. And if you look at this particular XY axis, you see we've got dedicated higher costs. It's going to be more red. It's going to have more higher administration. When you move towards the right-hand side, we've got lower administration, and we also have a shared lower cost as you start using things like software as a service, platform as a service, or even infrastructure as a service. But when you look at the evolution of data platforms, you're going to begin to notice that a lot less questions to ask when you are migrating away from these on-premise systems. On-premise systems require a lot of upfront questions. So you start out with what size servers, how can I scale, how many servers, how long does it take to acquire, how long does it take to provision, who monitors my servers, what packages should be installed, how often do I patch, what's my server utilization, how often do I do backups, what happens if there's a hardware failure. These are all kinds of really important questions when you start at the very beginning where you're at this physical data center. But once you move into the next level of IaaS, you no longer have to be concerned with the procurement of machines, and it also becomes easier to size your machines based on utilization. Once you move up to the PaaS level, your questions become even simpler. You really only need to be concerned with scale and also utilization. Finally, once you get to the top tier at pay-per-query, you're really only concerned with planning the architecture of the actual database rather than doing any of the hardware support. Some of the major services available from Azure are broken into 2 main categories. You've got relational and also non-relational. Starting with Azure SQL Database, it allows the ability to scale up, or the ability to put SQL Server on virtual machines. Additionally, you can use Azure SQL Data Warehouse. You will notice that Azure SQL Data Warehouse actually supports both relational and non-relational database. Next, there's Databricks. It's going to be an Apache Spark big data analytics service for data science and also data engineering. Next is Cosmos DB. It's a very unique database that's going to be globally distributed, and it's also multimodal, meaning it offers multiple types of APIs for using it. This includes MongoDB, Gremlin, Cassandra, Azure Table Storage. Additionally, it has its own proprietary SQL API. Finally, you've got HD Insight. It's a cloud version of Hadoop components. This includes Hadoop, Spark, Interactive Query, Kafka, Storm, and also HBase on Azure. If you're really looking at doing a lift and shift methodology to migrate virtual machines to the cloud, the easiest way is by using the infrastructure as a service. This allows you to choose from existing images, including SQL 2008 R2, 2012, 2014, 2016, and 2017, and also the web standard and enterprise versions. Or you can actually bring your own image. I've worked with several clients that did that exact thing. They were working on a very old system and the actual hardware was no longer to be supported, so they needed to move to the cloud, and that was one of the choices they made. It required a few updates to the schema. We finally get that updated and inside the cloud. Additionally, one of the things you can do is choose from multiple operating systems, including Windows Server 2008 R2, 2012 R2, 2016, even Linux and Ubuntu is available now. Microsoft IaaS allows you to provision your machines in just minutes, and even create templates for reproducing these environments over and over again if you need to. The machines have the ability to allow RDP and also PowerShell. The Azure SQL database is a relational database as a service. That is, it's fully managed by Microsoft. It's designed for cloud apps where near zero administration and enterprise-grade capabilities are key. It's perfect for organizations looking to increase their database to IT ratio. It offers elastic scale and performance while providing predictive performance levels. You can also programmatically scale out the database and have access to a dashboard of database metrics. It also offers business continuity and data protection. This includes the ability to restore self-service, you can do full disaster recovery, and also provide security to meet your compliance needs. Because Azure SQL Database is based off the existing SQL Server versions, it will feel familiar and is also readily compatible. It offers a fully programmatic interface and is completely self-managed. The Azure SQL Managed Instance is a fully managed deployment option designed for near-perfect compatibility for SQL migrations. You can use its Azure SQL Managed Instance to lift and shift on-prem SQL apps and then leverage unique Azure SQL features like linked servers, service brokers, and also database mail. There's 3 different options available for a managed instance. So just for a managed instance, that's a cluster of system and user databases that use shared resources. You can use this option to mimic the on-prem SQL Server functionality. Next, you have a single database. So each instance is going to have its own resources and functions like a single database on a SQL Server. It's really designed for development and use and for cloud. It also is cloud native. Finally, you've got Elastic Pools. It's a collection of single databases using shared resources. It's really designed for the development of cloud native applications with a multi-tenant pattern. You can also use this to optimize resources for databases with variable use requirements. The great thing about managed instances is that they offer easy migration and it's nearly 100% like SQL Server. For data migration, it offers native backup and restore functionality and log shipping. For security, it offers transparent data encryption or TDE, SQL audit, row-level security, and you can trust that your data is always encrypted. For programmability, you have the ability to use global temp tables, cross-database queries, transactions, link servers, and even CLI modules. On the operational side, you can have DMVs and extended events dynamic management views, along with the query store, SQL agent, and also DB mail. Finally, for scenarios, you can use your service broker, change data capture, and transactional replication. What if you want to actually use a non-Microsoft database? There is actually a managed community, including MySQL, PostgreSQL, and MariaDB. There's almost unlimited languages available and frameworks that you can choose from. With Azure, you can actually scale in seconds, and you have built-in high availability. You have enterprise-ready solutions that are secure and also compliant. You also get the industry-leading global reach. The Azure SQL Data Warehouse is a relational data warehouse as a service, and it's managed completely by Microsoft. It's the industry's first elastic cloud data warehouse with enterprise-grade capabilities. It allows you to support your smallest and also your largest data storage while handling queries up to 100 times faster. It provides elastic scale and performance and scales to petabytes of data. It provides you with a massively parallel processing and also instant on compute. Additionally, you can query relational and also non-relational data. It's obviously powered by the cloud, but it's also integrated into Azure ML, Power BI, and Azure Data Factory. Like most Azure services, it is enterprise ready with market-leading price and performance, You simply pay for what you need. With Azure, there's different types of storage that is available. Starting with LRS, which means locally redundant storage, you have multiple replicas across a data center. It does protect against disk, node, and rack failures. It does have 11 nines of durability, and the SLA is 99.9%. Next, you have ZRS, which is zone redundant storage, which means you have replicas across 3 zones. It does protect against the disk, node, rack, and zone failures. At this point, you have to 12 nines of durability, and it's available in 8 regions with an SLA of 99.9%. Next, there's GRS, which is geo-redundant storage. This means that multiple replicas across regions to protect against natural disasters. Normally, the regions are at least 300 miles apart. The replication to the secondary is asynchronous with 16 nines of durability. The SLA is 99.9%. Finally, you have RAGRS, which is read access geo-redundant storage. It offers the ability to have a secondary endpoint, and the secondary region has an RPO relay to a secondary that can be queried. This provides you with an SLA of 99.99% for read and 99.9% for write. There's also several types of storage options available inside Azure. Starting with hot storage. Consider this to be the storage of items you need frequently. The cost is going to be higher, but the access cost is going to be much lower. Next, you move into cold storage. These items are not accessed as frequently, so maybe there are files from a previous year, and you may need to access them once in a while. This tier lowers the storage cost, but also increases the access cost. And finally, you have the access tier. They're usually items that are an organization that are required to store because of compliance reasons, so there tends to not be a reason to access them on a day-to-day basis. This storage will be the lowest cost, but to access the data, it will actually incur the highest cost. Let's go ahead and do a demo of provisioning an Azure SQL Server from the Azure portal. For our first demonstration, we're going to create a SQL database in the Azure portal. So I'm just going to go ahead and click on Create. Inside here, first I need to define a resource group. I've already got an A to Z database set up, so that's going to be my resource group for this. For a database name, I'm going to go ahead and choose A to Z. So just add 999 at the end of that, just so it doesn't conflict with anybody else. Next, I want to have a server name. As you can see right now, there is not a server that's available for this, so I do need to click on New. For the server name, I'm just going to call this A to Z. And DB server 9999. Leave the location at East US. Because I am connected to Azure Active Directory, I can choose SQL Authentication, Azure AD Authentication, or use both SQL Server and Azure AD Authentication. I'm going to set myself as an admin. Go ahead and select. For the admin login, I'm just going to call it admin123. And give it a sophisticated password. That's all I needed for the actual server part of this. So I'll move on to and go back to the security of the SQL database, and it has selected the server for me. Now I can choose whether I want to use the Elastic SQL or not, so just yes or no. Now I want to choose the compute plus the storage, so I can configure what's actually it's going to look like. So I can configure this database. So I can choose what service tier I want, so vCore, purchase-based modeling. I can choose hyperscale, business critical, basic, standard, and premium. For this, I'm just going to go ahead and choose basic. I can see my DTUs went down and my max size for database is down to 2 gigabytes, so it's very, very small for what we're going to do. I can choose what kind of backup redundancy I want here, so I've got geo-redundant, zone redundant, or even local redundant. I'm going to go ahead and put this at local redundant. Moving on to networking, I can choose what kind of network activity I want. I'm going to go ahead and make this just a public endpoint. So I want to make sure that Azure services and resources have access to this server. I also want to add in my client IP address. This actually looks at the IP address that you're currently logged in as, so you can access this particular system. So you define how you want to connect to this. So with the connection policy, with the default, proxy, or a redirect. Move on to security. You can actually set up Microsoft Defender for SQL. Define a few want to actually use Ledger. It detects any type of tampering inside your data. We've also got identity for user-assigned and identities if you want to include that. Transparent data protection, but I'm going to move on to additional settings. For the data source, I'm going to just start with a blank. So I'm not going to choose from a backup or from a sample. On the correlation, just leave this as SQL Latin. And the maintenance, I'll just leave this at the default. I'm not going to worry about the tags, but go ahead and review and create, and click on create. And I'll be back when this is complete. So let's take a look at the resource. So I've got a server name that is available inside here. Inside here, I actually have access to a query editor. Since I set myself up, so I can choose a certificate for this. Since I'm an admin, I can go ahead and authenticate directly inside here. So you can see it's a web interface. I've got access to tables, views, and stored procedures, so very quick and easy. I can go into Quick Start, so I can get directly into the Azure SDK, Azure Data Studio. If I want to utilize and download SQL Server Management Studio or PowerShell, or even the Elastic APIs. So lots of useful information directly in this Quick Start. I have access directly into Power BI, so if I want to visualize data that is available inside SQL Server, inside Power BI, or if I want to include data from SQL Server into a Power App, I can do that directly from here. Or include information directly from SQL Server and utilize that inside Power Automate also. Under the settings, I can take a look at the compute and storage. We saw before, basically I have a max size of 2 gigabytes. I can still see the database utilization. My service tier is still at basic, but I could actually move this up to standard if I wanted to. Now I can see I've got more DTUs available to me. I can increase the database size if I wanted to, or even change the backup storage redundancy. Next, let's do a demo of provisioning Azure SQL Server using the Azure CLI. For our next demonstration, I'll be actually doing exactly the same for creating the SQL database and the SQL Server, but I'm going to do it from the command line interface. If you have any experience at all working with Microsoft products, you might notice that when doing command line interface, there have been quite a few limitations from the Microsoft side. But when you move into Azure, there actually is a tremendous amount of power available to you. So if you notice, I'm actually logging in with the bash interface, and this will actually be using the Azure command line interface, or CLI, but I can also use Azure Windows PowerShell also. So I'm going to set up a handful of variables first. So a lot of these will seem familiar from what we just worked through. So first I need to set up just a random identifier. So it's going to give me just a unique number. I'm also going to identify a location. Next, similar to what we were doing before, I'm going to take this unique random identifier and I'm going to create a resource group. So it's msdocs-azure SQL-rg, and it's going to give me that random identifier. Next, I want to create and configure the database. So this will be just a tag that we're going to have called create and configure database. For the server name, I'm going to add in a variable for server, msdocs-azure SQL-server. Now when I move in and define my database name, msdocs Azure SQL DB with a random identifier at the end. For the login credentials, just choose msdocs admin user and define a password also. Inside here, I'm also going to define a start IP address and an end IP address. Next, I'm going to run a couple commands. First one is going to create my actual group. So I've got AZ group create, it'll be resource group, and give me the location, pass in the location name, and also pass in the tag. I'll run this. And that was successful. So next we want to actually create our SQL Server. So it's AZ SQL Server create, pass in the server name, the resource group we're using, the location, admin user, and the admin password. And as soon as this is complete, I will come back. So now that we have the SQL Server created, we're going to define some firewall rules. So just like we were setting up before, so we've got firewall rules that we're creating. You have to add the resource group, the server, and we're allowing what IP addresses and the end IP addresses. Next, we actually need to create the SQL database. So AZ SQL DB, I'm going to be create, pass in the resource group, the server that we created, the database name, sample name that we're going to be using is AdventureWorks LT. The addition will be general purpose and family Gen 5. And as soon as this is done running, I will be back to demonstrate it. Now that it has been completed, we can go back to Azure, check on all resources. So we can see these names that I was putting in before, the MS-Docs-Azure SQL, MS-Docs SQL DB. So I can go directly to the SQL Server. You can see I can have multiple databases available inside here and choose the one that was created from our script. It looks exactly like what we're looking at when I created it inside the portal. I have access to the query editor. Additionally, just like on the other one, if I wanted to get access to Power BI, quickly get access to SQL data in Power BI, access to Power Apps is integrated in here also if I wanted to expose data inside of a Power App from SQL Server. Also from Power Automate if I wanted to choose SQL Server to be my data source. Inside here I can click on Compute and Storage and see what was actually defined in here. So as we saw from my script, it chose a general purpose. I could switch this to standard if I wanted to, choose different DTUs or a different max database size. Currently was set at geo-redundant. I could switch this back to locally redundant if I wanted to. Very easy to change all of this. Also have access to all the connection strings. So from ADI.NET, JDBC, ODBC, PHP, and also Golang. And then we're going to provision PostgreSQL on Azure. So this one, we're going to choose something a little bit different. So these are all the popular products. I'm going to choose See More in Marketplace. For this, we're going to choose Postgres SQL Server. So for this one, I'm just going to click on Create, and this will be coming up on a Ubuntu server. So I don't have to configure a lot of things. So what's great about the Marketplace, there's lots of available templates for you inside the Marketplace. So inside here, I'm going to go ahead and choose my resource group, A to Z group. A virtual machine name for this, remember this is going to be that Ubuntu server. There's A to Z Ubuntu 999. Region, I'll leave it at East US. I'm not going to worry about availability options, but it's something that is available to you. So if you want to set this up to have an availability zone, so you can have physically separate resources within the region, virtual machine scale set, or you could use an availability set. For security type, I'll just go ahead and leave this at standard level. And the image, as we saw before, I'm choosing this PostgreSQL, but there's lots of other ones you could choose from, but all the normal standard ones are available by default. You can choose the Azure Spot instance. Spot instance is available too if you want to assign a longer term. So this I'm just spinning up kind of randomly. You can choose a longer term if you want to choose a 1 year, 2 year, 3 year, and get discounted rates on your virtual environment. On authentication, I'll just choose the public key. Username, I'll leave this exactly like it is. I'm going to generate a new key pair and the key pair name. Go ahead and go on to disks. For the disk options, it's going to put me a default at premium SSD. I can choose standard SSD or even standard HDD. I'm going to go ahead and put it at standard. Move on to networking. It is going to establish a virtual network. Normally this is something that you would do beforehand. You can see it's going to take my region name and add in -VNet for that. My subnet, and also going to give me a public IP address inside here. Also has a network security group that it's going to create inside here. Let's go on to management. So I can have different boot diagnostics available to me, or I can even provide Azure AD if this was not a Ubuntu image. Move on to advanced. So I can choose different types of scripts that I want to run. or different ways I want to host this. So I've got capacity reservations available. Let's go ahead and review and create. And I'll be back when this is ready. I'm going to go ahead and create, and I will be back and show you what this looks like. Download the private key. So now it's been created. I'll go ahead and click on Go to Resource. So now I have a virtual machine inside here. So I can look at the different networking, the disks that are available inside here, the size that was created. I have lots of different access inside of this virtual machine. And you can see if this is actually running Postgres inside here. Let's take a look at some of the non-relational database types of storage that are available. So there is Azure Table Storage. It's a NoSQL offering that offers key value pairs. So the data is going to be referred to as rows and columns, but it's not like a relational table. Therefore, the rows have a key, but the columns are the variant and based on specific data stored in that row. There's no relationships, there's no stored procedures, secondary indexes, or even foreign keys. Data is normally just very flat, so think of a normal Excel or CSV file. In order to access that table storage, a user is going to have to be authenticated. The request can be made through SDK libraries, OData, and even link queries. The table is going to utilize partitions. It's going to give that ability to quickly group data and help increase the efficiency of your queries. The key for an Azure Table Storage is going to be the partition key and the row key, and it's going to be a clustered index. Items in a partition are stored in row key order. Because of this, both point and range queries are efficiently handled. Data can be stored as numbers, as strings, or even binary data, and can be up to 64 kilobytes, with a max of 252 columns and a max row size of 1 megabyte. Table storage is actually a really great addition to web apps. So you can store sensor data or even work with event log data. Next, let's take a look at Azure Blob Storage. Blob is just an acronym for Binary Large Object. Depending on your storage needs, you'll need to choose between block, page, and also append blobs. 99% of what you'll use on a daily basis is going to be videos, audios, documents, and images. To create blob storage, you need to create a storage account. Then for the blob storage, you need to use a container. So inside these containers, you can have a virtual file structure for folders and such. But even though if it appears to be organized like folders, the blob is really just referenced by file and folder name instead of just the file name. If you want to create hierarchical data, you want to use the data lake option. When you provision a storage account and container, you can choose the default tier, but items can be at the container at various tiers. Tiers are ideal for mapping your throughput and your storage need to optimize your cost. If you're going to be accessing the data a lot, then you want to use this hot storage. It's going to cost a lot less. If you do need periodic access, you can use cool storage. It's going to cost less to store, but more to access. If you need to retain it for legal reasons, then use archive. You can also set alerts and move items from one tier to another tier. The exception to this is moving out of the archive, which is going to require Azure to actually perform that work. But for your own uses, you will create alerts or rules to auto-cool an aging document, or perhaps move to archive after 90 to 180 days. You can go from archive to either hot or cool, or you can go from hot or cool to either of the two. It's not a waterfall of tiers. Finally, using blob storage allows you to quickly set some options for disaster recovery and auditing. You can have no soft delete or soft delete with a retention of period of like 7 to 14 days. You can also add in versioning to items to use the storage account as if it were your own Git repository, where you can get previous versions of a blob from history. Snapshots allow you to see what the blob storage looked like at a specific date and time. And there's also an ability to change the feed to notify people when blobs have actually changed. Next, take a look at Azure File Storage. Azure File Storage is really your go-to source for sharing files within your organizations via the cloud. With file storage, you can lift and shift an entire SAN, so thereby migrating an existing shared drive to the cloud. Additionally, you could replace services like Dropbox with an Azure Files share. AFS is going to use Server Message Block Protocol over port 445 to connect and work with your files. You get full authentication and authorization available within Azure, so you can ensure that all your data is going to be secure. You can also use it in a hybrid scenario that's going to mirror your on-prem device and integrates well with on-prem or even cloud services. Each of your AFS accounts can have up to 100 terabytes and also 2,000 concurrent connections. Tools you can use to interact with it include AZ Copy Utility, the Azure Storage Explorer IDE, or the Azure File Sync service. I introduced Cosmos DB a little bit earlier, but let's take a look at some more details about it. It is the NoSQL offering of choice for Azure, and like table storage, Azure Cosmos DB is a NoSQL offering that stores your documents. This is going to be your primary storage. It stores graphs, also key value pairs, just similar to table storage, or column families. These are going to be rows that have many columns mapped to a row key. Within Cosmos DB, there's many different API offerings. For all new projects, the recommendation is to use the SQL API. If, however, you have an existing project or team that is highly skilled in one of the other offerings, you may choose one of the compatibility APIs for Table, Cassandra, Mongo, or even Gremlin. Additionally, there's a tool that will help you migrate your data from an existing implementation into Cosmos called the Azure Database Migration Service. Under the API offerings, you've got obviously table storage to store and retrieve documents, switching from Azure Table Storage to Cosmos DB without having to rewrite your application. On Mongo, you can use MongoDB applications against Cosmos DB. You can still migrate your data into Azure this way, leveraging your existing apps. For the Cassandra API, it's the same as Mongo, only Cassandra-based. On Gremlin, it's another API for graph objects. In Cosmos, the data is still managed as documents, but using Gremlin allows you to run queries against the graph. The primary storage mechanism in Cosmos DB is the document. It's a JSON object. Cosmos manages the documents using a Cosmos account with one or more databases, and each database has one or more containers. In the containers, the documents are organized by partition and key. Unlike table storage, Cosmos does not recognize the documents by key value. Cosmos database containers can store up to 10 GB of data per partition. Each document is structured in JSON, so there's no relational capability and there's no guarantees about the columns associated to a key. It's going to give you the flexibility you need to model your data. Documents are generally denormalized data, but note that the document itself can have nested objects due to the nature of JSON. Cosmos DB has two primary benefits. The first is this global replication that happens throughout the world with leading performance and latency. The second benefit is the ability to choose your level of consistency. The manner of storage based on consistency is incredibly important because each of these has different advantages and some disadvantages, depending on your scenario. For example, eventual consistency is going to be your weakest consistency at all, but it offers immediate read capability in the region where writes were performed. However, this means that during the replication, other regions may be reading dirty or old data until the replication is eventually completed. As far as the left is going to be strong consistency. This is going to be the strongest available. This means that the data is written and cannot be read in any region until the replication has taken place around the globe. The drawback here is that you may have to wait a few minutes to read the data after writing. Some examples that you can view for this is if you want to have this strong consistency, say you're doing a e-commerce transaction, you want to make sure everybody actually sees all the valid details before it actually performs. You want to have it valid everywhere in the world before you actually do that. On the eventual consistency, if you're doing something like Facebook where somebody likes an image or makes a comment, it doesn't necessarily have to be immediately replicated around the entire world. Cosmos DB enables you to specify how inconsistencies should be handled. And it's going to provide the following options. So you've got eventual, it's going to be the option for the least consistent. You've had consistent prefix. This option ensures that the changes will appear in order, although there may be a delay before they become visible. In this period, applications may see old data. You have session, which makes a number of changes, but they'll be all visible to the application and in order. You also have bounded staleness. There's going to be a lag time between reading and writing the data. You can specify staleness whether as a period of time or a number of previous versions that the data will be inconsistent for. And then there's finally strong. In this case, all the writes are going to be visible to clients after the changes are confirmed as written successfully to all replicas. Here's a simple map that kind of gives you a little bit of a decision tree to figure out what's going to be the best API to use when you're looking at Cosmos DB. So the first question that you want to start off with, are you building a new app? So if you're going to choose the no, then you want to actually look at what is your app coming from. So if you're choosing Cassandra, Mongo, Gremlin, table storage, or another database application, then you want to go into your modernization guide. But you want to reuse the existing technologies. If you choose the yes route, then you want to take a look at if you have any experience with these tools. So you want to leverage the experience from your teams that they have right now, whether you go down the Cassandra route, Mongo, Gremlin, or just go into the core SQL. Next, we'll do a demonstration of creating an Azure storage account and also a Blob container. For our next demonstration, we'll be creating an Azure storage. It's actually available as a popular product, so scroll down and see the storage account. Just click on Create. So the basics, I'll choose my subscription. The resource group's coming up as the default resource group, which is perfectly fine. You can also choose this A to Z database into this session. The storage account name. A to Z basic storage account, 555. The region, let's go ahead and leave this at East US. For the performance, I'll leave this at standard. There also is premium available. Also, you can see it down here. I can choose what kind of redundancy I want to have. For our demo, I'll just leave this at locally redundant storage. Move on to advanced. You have different security settings. I've got enable Blob public access. You require secure transfer for REST APIs. You can also enable the data lake storage Gen 2. You can also have the SSH file transfer protocol. For Blob storage, you can decide the access tier for hot or cool. You can also enable large file shares for Azure files. On the networking side, I can decide whether this is going to be a public endpoint or not. For all networks or selected networks or just an entirely private endpoint. On the networking side, you can choose between Microsoft Network Routing or just Internet Routing. We move into data protection. You can see we've got the ability to enable soft delete for blobs, containers, and also soft delete for file shares. For encryption, you can see we've got Microsoft managed keys. You can also do customer managed keys, so if your compliance actually requires you to provide your own keys, you can utilize this particular feature. Go ahead and click on Review and Create. And when this is ready, I'll walk through it. Now that it's ready, so inside here I've got the overview page. I can choose to open and explore. So this will actually utilize Azure Storage Explorer. Basically, it's a Windows application that allows you to interact with this while that's loading. Go into data storage. Take a look at containers, and here you can see where I've got one already for logs. And create another container, like file folders in normal Windows Explorer. But now you can set up a public access level. So I've got private, no anonymous access. You can have blob, anonymous access for blobs only, or container, anonymous read access for containers and blobs. Go ahead and click Create. You can see I've got a demo container in here. You could set up a private one if you wanted to. And inside each of these, that's where you can actually upload files inside here. So I'm going to create a new text file. Just going to call it test. File save as. And just throw it in my documents. And go back over here. Here are my documents. My new 19.txt, and just click on upload. Now you can see how this file gives you a tremendous amount of information with it. It does have version control. I can do snapshots. I also generate a SAS, which actually gives me a timed access link, so it's this shared access signature. So it's going to grant restricted access to that particular blob. You can give it signing keys. You can provide what kind of permissions this user has, so you can update it, write it, delete access if you want to. You can also define when the start time of this access is going to start and when the end time is going to be. So you can set up the start and the expiry for it. You can also explicitly define IP addresses. So if you just want to click on this, generate the SAS token URL, and this is what it's going to look like. So you've got the SAS token, and you've also got a blob storage. So I'm going to click copy the SAS URL, just copy that over, open a new tab. Just want it to be unsafe just because it doesn't know the file type, but it has a basic text message inside here. Currently my access tier is set at hot. I can actually switch this around to different tiers if I wanted to. So you can see right here I can change the tier. So what we were talking about in the presentation, if you want to switch this to cool or archive, very easy to swap these around. You cannot go directly from archive to hot. You would have to go from archive to cool to hot. But now I can go from cool to hot or from cool to archive from where it's sitting right now. And we'll create an Azure Cosmos DB database and also a container. So next we're going to create a Azure Cosmos DB database. So it's available on one of the popular products. So we'll click on Create. You can see the different APIs. So what we're talking about before. So you can choose which API suits you. You've got Core SQL. You've got the Cosmos DB for MongoDB, Cassandra, basic Azure table, or Gremlin if you want to use the graph. For this one, I'm just going to go ahead and choose the MongoDB. For the resource group, I'll go ahead and choose this A to Z database. For location, I'm going to choose East US. You can see on capacity, I can choose provision throughout or just choose serverless. I'll go ahead and leave the default for this. I can apply for a free tier discount. Definitely, the first time you've ever invested with Cosmos DB, always check the free tier discount. It does get quite pricey if you're not used to working with it. You can choose what kind of redundancy you would like. So we've got geo redundancy, which is not able to be disabled. Multi-region rights, currently disabled, and availability zone is also disabled. We've got network connectivity. Let's click on networking, so you can see whether it's available from all networks, public or just private. Also can set up a backup policy, so whether it's periodic, continuous. The backup interval is in minutes. Backup retention is currently at 8 hours. Also, you can define the backup storage redundancy, either geo-redundant, zone redundant, or locally redundant. I'm just going to make this locally redundant. For the encryption, you can define, like I mentioned before, either the service managed key, or if you want to provide your own customer managed key, you can do that also. I'm not going to worry about the tags, and go ahead and click on Review and Create. Click Create, and I'll be back when this is done provisioning. So now we have our Cosmos available for us. See, shows you how to connect to your Cosmos DB, so you can choose which platform from .NET, Node.js, or MongoDB, Java, Python, or even others. Let's go into our Data Explorer, and we're going to create a new collection. Since this is Mongo, first I need to create a database and then a collection. I'm going to call this a to-do list. Collection, which just call it items, and inside here, our shared key will be category. Click OK. When this is done provisioning, I will be right back. So now I have a database and I have a collection inside here. So items, and I click on documents. If I want to actually create a new document, and click on new document, it's going to give me just a very simple sample one. As you can see, I do have to include category. If I do not include category, since this partition is based off that, it would not partition or would not accept this value. So I'm going to go ahead and click on save. As you can see, it's going to add in an item right here. So you can see the category is showing up as personal. This is as easy as it is to create a Cosmos DB, add a database, and add an item to a collection. For a quick review of what we went over, first we went over big data, the data platforms, the Azure Data Portfolio, did a few demos around that, also the non-relational database systems, and a few demos. I really appreciate your time for attending.